Hello everyone, my name is Rohit Singhal and we were discussing about the hydrocarbons. In the previous lecture, I have discussed about the physical properties of the saturated hydrocarbons, that is alkenes. Now, in this class, we will discuss about the chemical properties of the alkanes. So, let us discuss. Chemical properties. As we know that hydrocarbons are the molecules of carbon and hydrogens, which in generally do not react very too much with acids or base, but in certain conditions they are reactive. In which conditions they are reactive, what they react with, we will see in these chemical properties. So, starting with a reaction known as substitution reaction. This saturated hydrocarbons react only under the certain conditions. That certain conditions are, we will know, get to know. Substitution reactions. What is the substitution reaction? We know what an alkane is. Let us take an example of methane. So, what is the substitution means? Substitution means replacing something by another group. So, if we replace one hydrogen or more than one hydrogen of alkanes with some another group, for example, halogen, for example, sulfone, for example, nitro group, that will be known as the substitution reaction. So, replacing this H by this halides, nitro group, sulfonic groups, etc., will be known as substitution reaction. So, if we discuss about replacing with the halogen, that will be known as halogenation reaction. Halogenation. So, let us discuss more in the detail of the halogenation reaction. If I take the example of methane and I have to replace it, let us say example with the chlorine. So, what happened? Replacing one atom CH3 Cl and it will form one HCl. As I have already told you that hydrocarbons, saturated hydrocarbons are not much reactive. So, obviously, directly adding Cl2 to any of the alkanes will not going to give us the alkyl chloride. So, we require certain conditions for that. So, the conditions are either we require in the presence of light, that is also represented by H nu. You must have studied this Planck's H nu, light, or we can also do this reaction at high temperature. For example, almost 570 to 600 Kelvin, then we can produce the same. Okay. So, in order to produce alkyl chlorides or do the halogenation reaction from the alkanes, we require either the conditions of light or high temperatures. However, there is one also thing to keep mind in this, that this reaction is not controllable. What does that mean is, the reaction does not stop here CH3Cl. It can further react with Cl2 and can form CH2Cl2, can further react with Cl2, can form CHCl3 and further CCl4. Now, it is very difficult to stop the reaction at any one step. For example, if we need to substitute only one hydrogen by the chloride atom, so it is difficult to stop the reaction at this condition, because it goes through a chain of reactions and the hydrogen kept on substituting by the chloride group. So, how is this reaction taking place? Let us go through the next mechanism of the reaction. So, let us talk about the mechanism. So, the mechanism is the mechanism it follows is radical polymerization, or we can say radical chain mechanism, not polymerization, radical chain mechanism. So, it goes through by formation of a radical. So, how the reaction takes place? Any radical mechanism has three steps. One step is initiation, the second step is propagation, and the third step is termination. So, what is initiation? Initiation means generation of radical. Generation of radical. What is propagation? Chain elongation, we can say, or not chain elongation, we can say the reaction kept on. Okay. The propagation means the reaction is continuously going on. The reaction is continuous, in process or in process. And termination means the destroying the radical. So, how this reaction now, three basic steps: initiation, propagation and termination. Initiation means the generation of the radical, propagation means the use of that radical to form the desired substituted product, and termination means to end the reaction and to destroy the radical. Why this reaction now is uncontrollable? Because it goes through mechanism of radical mechanism, and radical reactions are difficult to control. So, that is why this halogenation reaction which goes through radical mechanism is not that much easily to control. So, let us see how it goes through these three steps. Let us discuss these steps one by one. Initiation. So, what happens is, as Cl bond is weak, Cl bond is a weak bond. So, what happens that when light strikes the Cl2, it homolytic cleave, this is called homolytic cleavage. I have already told in previous class, if there is symmetrical distribution of electrons from a bond, it is called homolytic cleavage. So, homolytic cleavage of the bond occurs to give the Cl radical. Okay. So, what happens next is the step propagation. Is the step propagation. What we have formed? We have formed chlorine radical in first step. Chlorine radical. Okay. Chlorine radical we have formed. Now, what we will use this chlorine radical in this reaction, in the step propagation step. So, what happen is, now methane will react with the chloride radical to give one CH3 radical plus HCl. What happened in this reaction, in this step is CH, H, H. That one of the CH bond cleaves homolytically to give H radical and CH3 radical, and this H radical combines with the Cl radical to form HCl. Okay. So, in this sense, this CH3 radical has been produced. Okay. So, now the CH3 radical, what happens is CH3 radical, now we have to what it can do? It can react with a Cl2. Now, what to form a CH3Cl and a Cl radical. Now, what happens in radical mechanism is that our one radical initiates the breaking of another molecule into a ligand. So, what happens in first step initiation, the Cl2 molecules in the presence of light breaks into the Cl radical. The Cl radical is been produced, is being used in the reaction in the propagation step, where Cl radical attacks the methane molecule and creates H radical and the CH3 radical. The H radical combines with the Cl radical to give HCl, whereas the CH3 radical in the another step can react with Cl2 to form CH3Cl. Now, what can be the possibility that this CH3Cl can again react with a Cl2 molecule to give what? To give, or let us say not Cl2, but a Cl radical also it can form. Here it can be Cl2 or Cl radical can react with Cl3 radical to form a CH2 Cl2 and H radical, like let us use HCl2 only. Okay. CH3Cl can react with Cl2 to form CH2Cl2 plus HCl. Okay. This is the possibility. So, this is the way how the chain propagation means the substitution kept on going on, the hydrogen getting replaced by the chloride atom in the steps, unless it can it is possibility the reaction stops at one substitution, two substitution, or the possibility is also the reaction can go further up to the substitution of all the hydrogens by the chloride atoms. So, how to terminate this reaction? Now, the third step involves the termination. Termination. What happens in the termination step, that the two radicals combine to form a molecule. So, for example, Cl radical can combine to form Cl2, termination A step. Another, it can be possibility a CH3 radical has been formed. Another CH3 radical, it can combine to form CH3 and CH3. What can be the other possibility? There is a CH3 radical, yes. There is a Cl radical, yes. It can form a CH3Cl. So, all of these are the side products of the reaction. Okay. So, this is the termination step, means destroying the ligands. Sorry, ligands I am saying, sorry. Termination step means destroying the radical. Okay. The two radicals combine to give a molecule. Okay. So, this is the basic halogenation reaction we have studied now. Three basic steps. Substitution reaction by the halogen is called halogenation. It goes via chain radical chain reaction mechanism. 3 steps are involved: initiation, propagation and termination. Okay. So, that is how it is. Now, there are few properties for this reaction, we can say. What happens, a 3 degree alkane reactivity order, we can say a reactivity order. What is reactivity order? Reactivity order, 3 degree alkane react faster with 2 degree alkane and then 1 degree alkane. I have told 1 degree, what is 3 degree, 2 degree, 1 degree. If our carbon radical attached with one carbon, it is a 1 degree. If a carbon radical is attached to 2 carbons, it is a 2 degree, and if a carbon radical is attached with 3 carbons, it is a 3 degree radical. Okay. Now, what happens is the third degree radical is more stable than the second degree or first degree radical. So, that is why if I take an example of, let us suppose ki ethane CH3 CH a 2 degree alkane. Okay. And a 3 degree alkane. Now, the substitution of this H will be faster than this. This is 1 degree alkane, this is 2 degree alkane, this is 3 degree alkane. So, the 3 degree alkane reacts faster, because what happens, a radical is going to form, and third degree radicals are more stable than the second degree radicals and the 1 degree radical. So, that is why third degree alkanes reacts faster or gives better halogenation reaction in terms of reactivity. Another thing is reactivity order, we say that the F2 reacts faster than Cl2, then Br2, then I2. The reactivity order for the halogens will be fluorine, chlorine, bromine and iodine, but fluorine we generally do not prefer, because these are too, it can be explosive, too explosive to use, or we can say uncontrollable. Okay. So, that is why we do not use the F2 in the substitution reaction. Using I2 or substitution by the iodine is really a slow process, and to substitute that we have to use some another reagents, for example, HiO3 and that so on. Okay. So, that comes to be the halogenation reaction. So, now we have discussed about the halogenation reaction, what are the reactivity orders for the different molecules, for the different alkanes, what order goes for the halogenation in the reaction, fluorine, chlorine, bromine, iodine, that is the order. in the descending order it follows. Okay. So, let us move on to the second chemical property, that is combustion. Combustion we all know means heating in presence of heating in presence of air. So, if I heat in presence of air, so the alkanes undergo the complete alkanes undergo complete combustion, and we all know that complete combustion means the formation of the CO2 and H2O. If I need to balance, it will be like this 2H2O. Okay. If I will form another molecule, okay. So, this is how, if the complete oxidation gives the complete combustion gives CO2 and H2O. This is a gas, methane, oxygen is a gas, carbon dioxide is a gas, and H2O will be liquid. So, what happens is that the combustion, alkanes combustion generally give the complete combustion to form the carbon monoxide and water as the products. However, if incomplete combustion is done, if incomplete combustion so what it can form is solid carbon and water molecules. Okay. And we know that the carbon solid is generally used in the, this carbon is used in the ink printers. So, the incomplete combustion, if the incomplete combustion of alkanes is taking place, it will form the coke, that is called carbon solid carbon, and it is used in the form of ink printers. So, that is the combustion reaction. Moving on to another chemical property. So, the next chemical property can be the oxidation reaction. Okay. Oxidation reaction. Now, oxidation reaction, what is the oxidation reaction means? For example, if I am adding oxygen, now you must be wondering that we have added oxygen already in the combustion process. So, what is different it's going to in the oxidation process? Though combustion is also a kind of oxidation reaction, but if we do the this oxidation reaction in presence of some, let us say some catalyst we are taking. For example, let us suppose we are taking some copper catalyst, okay, at high temperature and high pressure, let us say 100 atmosphere. So, what it can form? A methanol. Once one of the hydrogen can be replaced by the OH molecule. So, this will be the, yeah, this is now this is the balanced reaction. So, this oxidation reaction, though it is using the oxygen as similar as the combustion reaction, but now we are using the different catalyst. Above it was only the heating conditions, now we are using some catalyst. So, how that catalyst, how this is going to produce different moiety as the product, that we will discuss in the next class onwards. Okay. So, for now just this is it, we have discussed about the halogenation, the substitution reactions and the combustion reactions. The rest we will proceed in the further classes. Thank you so much.